We're continuing on in 9.2, hypothesis testing for the mean when the sigma is known. So here we go with another example. A report suggests that consumers are spending less due to a realization that excessive spending does not make them happier. A researcher wants to use debit card data to contradict, okay, so they're trying to contradict something, the generally held view that the average, okay, now we know we're dealing with mu, spent annually on a debit card is at least $8,000. She surveys 20 consumers and asks them how much they spend annually. The results are given below. By below, I put them over here. It is assumed that the population standard deviation is 500 and that its spending is normally distributed. Test the claim. All right, so if we're going to test a claim, we have to start at the null and alternative and go all the way to the end. So first we're going to start with the null and alternative. So what's going on here? We know that we're talking about the average, so we're going to put mu. And it says 8,000, at least 8,000. At least is greater than or equal to. It's got an equal to, so it goes in the null. So how do I contradict greater than or equal to? Well, that's just going to be the opposite of that would be less than 8,000. Now, what's the claim? This researcher wants to contradict it. So this is the researcher's claim. It's not the New York Times claim. That would be the null. But the researcher wants to contradict it. So now that we have this here, let's get some stuff up here because what do we know? We know that n is 20. We know that sigma is 500, and we know that the significance level we're talking about is 0.01. So now if we want to calculate the z, we need x bar minus the mu in question over the sigma square root of n. Well, we don't have x bar, but we can get it from Excel. So what we're going to actually do is we can actually do a lot of this in Excel. So if I want the average here, or the mean, I would just highlight all that up. So I get that the average here is 7866. Now that I have that average, I can just calculate it right in Excel if I wanted to. So that would be the test statistic would be the average. And I'm actually going to use a parenthesis for the numerator. The average minus 8,000 divided by parenthesis. The sigma is 500 divided by the square root of n is 20. And I get the z-score, so the test statistic is z equals negative 1.2. Now let's draw that out. What is that? So we know our z is negative 1.2, but let's look at the alternative hypothesis is less than. So we're going to be able to shade it over here, which is great because we can find, remember that this is the p-value, this probability. So the p is equal to, so we can type that in. That's just norm.dist. We know that the x is negative 1.2 and it's normal. So we get a p-value of 0.115. You could say 1 or 0 there. So we get our p-value, we get our test statistic. Now, we can make a decision. If the p is low, the null must go. So what is the p compared to the sigma level? So how does p compare to 0.01? And I like to start by looking here. 1, 0. This is greater than. The p is not low, so we do not reject the null. And another way to say that is we accept the null. So what's the null? Well, the null is not the researcher's claim. So there is insufficient evidence to support the researcher's claim. And that is how you do a full hypothesis test. It needs all of those pieces. Here it is written out for you if that's helpful. So go ahead and give these a try. Press play when you're ready to see the solution. And there you go. Now, you can also do confidence intervals for hypothesis testing if if you want, or if, I guess you wouldn't want, right? The question would ask you to do a confidence interval. So here's just an example of how we can kind of bring in what we've done previously. So if we wanted to use the confidence interval approach to redo that previous example from the previous slide. Now, in the previous example, we already found that the null and alternative was equal to, and then it differed from. And again, we did this in the previous video. And we had a sample of 30, and the sample mean was 622.85, and our sigma is 65. So we've got all this data here. So if we want to redo this, we want to use the confidence interval approach. So let's go back here. So the confidence interval approach basically says this. We need our mean. We need the z-score associated with that confidence level. We need the sigma and that, and we can calculate it. So maybe it's even a little bit easier. Now, how do we know if we want to reject? We reject the null if this value does not fall within the confidence interval, and we do not reject if it falls within. All right, so we would do x bar plus or minus the associated z-score times sigma over the square root of n. So what do we have here? We have a 5% significance level. So a 5% significance level, 0.05, assumes that it's a 95% confidence level. So what is the z associated with 0.025? Remember, it's the alpha divided by 2. Or what is the associated z-score for 95%? 1.96. So we've got 622.85 plus or minus 1.96 square root of 30. So when we type that into our calculator, the margin of error is 23.26. And so we can plus or minus on either side here. So if we subtract 23.26, we get 599.59. And if we add, we get 646.11. So let's go back here. We're going to reject if it does not fall in the confidence interval. So let's look at this value here. Does 606 fall in this value? And it does. It would fall in here. So we do not reject the null because it falls in the given region. So if we do not reject the null, if we recall here, let's go back. The researcher believes that it is different, but we're not rejecting the null. So there is insufficient evidence to support their claim. It doesn't differ, which is the same thing that we got in hypothesis testing, but just in a different example, or a different method, excuse me. So there is the solution, and that concludes section 9.2.